Joining us today is Derek Macauley, Director and Technical Consultant, Promet Engineers, who will be speaking at IIR's FeTech 2010 on the 14th to 16th of September in Fremantle. Hello Derek, nice of you to join us.
Good afternoon, James.
First of all, can you start by explaining why magnetite is currently receiving renewed interest from the mining industry?
I find that a very interesting question. I'm not sure I've ever been asked that before. It would stem, I think, from the need of China to spread its sources of ore, and China itself is a big user of magnetite from indigenous mines. There is no real attraction yet, although it might be happening from the other Asian users of ore, such as Japan, Korea, and Taiwan. They are showing some latter interest, but not the same as China. And I think it's the Chinese influence that is saying, we use magnetite, we know how to use it. We do want to spread our sources of supply and maybe buy into those sources. And there is not a lot of appeal from the normal companies that supply in getting into magnetite. So I would believe it comes from that end of the game, that China is pushing that avenue of supply onto Australia in particular.
And what are some of the economic and environmental benefits of using a magnetite feedstock for iron production?
Magnetite does cost more to produce a usable product in a steelworks. It then needs some additional reason to use it. That reason is that a good magnetite can be beneficiated to maybe 4, 5, even 6% higher Fe content than hematite, the normal DSO hematite ores coming out of Australia. But here I'm talking Australia only, and not Brazil, which is another game again. If you look at the iron making process, and in background I'm more an iron maker than I am an iron ore man. If it's not the amount of iron I'm desperately interested in at this level, it's the amount of other materials, they would call the gang materials, that I have to get rid of. And the cost of getting those gang materials out is very high, probably from $7 to $15 for every 1% in the ore per ton of ore you use. And so if you look at, you got to look at the whole value train. And before, I don't think anybody in Australia ever really understood the game of iron making, and has poo-pooed the idea of magnetite being of value as against hematite. But if I look from an iron maker's point of view, you give me some very clean material, I start to save money fairly quickly. Now, the second part of that is magnetite generally comes very free of phosphorus, and phosphorus is of major concern to steelmakers. Too high a phosphorus means they are limited in their production range of steels. And if as an iron maker try and get that phosphorus out, it costs me a lot of money. I'd prefer to buy an ore without that phosphorus. So in the end, I can make a cleaner steel as a steel maker. I can recoup the higher outlay of buying that magnetite from within my processing. There is a third benefit which is not yet there, which is because I am not now using so much energy to create steel from the ore, I am saving on environmental emissions, particularly in this case the CO2 emissions. Although also there will be the nitrogen oxides emissions will be reduced, and so will dust emissions.
Can you run me through the Promet OREX value in use software model?
Yes, it's basically, it's a model that tries to run through the process from receiving iron ore through either sintering or pelletizing or maybe even direct feed through the blast furnace and through the steelmaking process. It looks at a new ore being introduced to any currently operating steelworks, and it tries to rationalize the use of that ore both from a process point of view and from an economic point of view. And so with OREX, I would introduce some of these ore, such as a magnetite, into a burden mix, as they would call it, for the blast furnace. And I would attempt to work out, firstly, its value to the steelmaker compared with a benchmark value. And secondly, I would try to look at the effects that would have on my processing. And the two effects could be, if you have the ability to do it, is extra production and a wider range of steel. So OREX doesn't quite get there, but what it does do for you is it takes that ore and it tells whoever owns that ore what its value would be in the current marketplace that exists in Southeast Asia.
And how can OREX aid in reducing fossil fuel emissions released during the iron making process?
Well, whether OREX does that or it's a tool for understanding what's happening, I think it's more a tool. And that tool is, we have now adapted the OREX model to produce a CO2 footprint for any given ore from whatever source. So if you picked an ore from Brazil, we would take all the transport costs and the relevant CO2 emissions, and then its net emissions within the steelworks. Compare those with, say, a magnetite that comes from Australia, and immediately, I think, and this is an amount of work we've just completed, the effect of magnetite from Australia into China on CO2 emissions is very positive as compared with an equally clean hematite ore coming out of Brazil. So we would put it that OREX could prove that even though magnetite in Australia costs more to produce, its net effect in China is to have associated lower CO2 emissions, which are fairly substantial.
You're speaking at IIR's FeTech conference taking place on the 14th to 15th of September 2010 in Fremantle. What will you be discussing in your presentation? It
will be a paper that's trying to promote not only the economic benefits of magnetite, and here we're talking magnetite in relation to from Australia into China, where we're also talking about the environmental benefits. And we're hoping that the paper will adequately demonstrate that magnetite is not the poor cousin to hematite, particularly in Australian terms.
Derek Macauley, many thanks for your time today.
Thank you, James.